All right, morning guys. With section 3, day 2, we're going to do some things called finding reference angles. Then we're going to use those to evaluate the trig functions. And those are my two main objectives today, is to finding reference angles and then using the reference angles to evaluate trig functions. Okay, so first of all, what's a reference angle? What you're going to do, or going to be asked to do, is you're going to be asked to draw a angle, just like you did the other day, and then you have to then find the reference angle. The reference angle is the angle that is formed the quickest way possible with the terminal side and the x-axis. And what I mean by that is if I draw an angle like this, okay, that started at the x-axis and went all the way to here, that's the angle. The reference angle is this little spot right there. This is the reference angle. Okay, it's the one that makes it quickest way possible back to the x-axis. If I draw another one, if I have if I have it coming down here, then the reference angle is this one. Okay, we went all the way back to here, but the reference angle is the short one right there, in between, whatever makes it quickest way possible back to the x-axis. So as far as the way that goes, I'm going to give you a formula to kind of go off of, kind of a basic one. 0 degrees, 90 degrees, 180 degrees, 270 degrees, back to 360. Or if we're in radian measure, this is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi. Don't bother me. Alright, so if we're in quadrant 1, the reference angle is the same size as your angle. If you're in quadrant 2, in order to find it, one of the ways you could do it is you take 180 minus whatever your theta is. That's if you're in degree mode. Or you take pi minus whatever the radian measure is. If you're in quadrant 3, then you would take the angle minus 180. Or the angle minus pi in order to get that. And if you're in quadrant 4, which is this one down here, you take 360 minus whatever your theta is, or 2 pi minus whatever your theta is, based on if you're in degrees or if you're in radians. Okay, so that's what we're going to do for this first one. So what they're going to ask you to do is they're going to ask you to sketch the angle and then find the reference angle. So here's what you would be asked to do. It will say the angle is 210 degrees. So if I sketch 210, that's 90, 180, 210 should be somewhere in here. Since that is in quadrant number 3, if I use that little formula I just gave you, it's 210 minus 180, so my reference angle is 3. And that's this little angle right in here. This spot from the red line to the black line is 30 degrees. That's how you find a reference angle. So on the first half of your assignment today, this is what you're going to be doing. You're going to be sketching the graph and then coming up with the reference angle. So let me give you another one. I have negative 260, which means I go back this way. 90, 180, not quite to 270. But my reference angle is still this one that comes back to the x-axis. So for that one, what I would do is I'd take 260 minus 180, because I'm getting it back to that line as quick as possible, which is 80 degrees. Now I know that the initial angle was a negative, and that just meant that we went clockwise instead of counterclockwise. But as far as the reference angles, they should always be positive numbers. So for that one, it's an 80-degree angle is what it made. Okay. Now on the flip side of that, they're also going to give you ones like this that are in radian measure. Now, because you guys haven't worked with radians all that much, the easiest thing to do would be convert that into degree form, which would be timesing it by 180 over pi. The pi's cancel. And if I take and multiply that, 7 times 180 divided by 9, I got a negative 140 degree angle. So if I sketch where that belongs, negative 90, not quite to the 180, somewhere in there. Okay, so now our reference angle is this one right here. So if I take 180 minus 140, I end up with 40. So my reference angle is a 40 degree angle. But our problem's not in degrees. It's in radians. So if it's in radians, then your reference angle has to be in radians too. Which means now I'm going to take and times it back by pi over 180 to get it back in radian measure, not degree measure. So when I reduce that fraction, I get 2 pi over 9. Okay, so my reference angle is 2 pi over 9. The angle that we drew was down here, and we should be good to go. Okay, give you one more. We have 15 pi over 4. Again, quickest way I think to do it is to take 180 and divide it by pi. My pi's cancel. And when I take 15 times 180 and divide it by 4, I get 675 degrees. So that's going to mean some turns. We're going to turn around that thing. 90, 180, 270, 360, 450, 540, 630, blah. We're stopping somewhere in there. So now the reference angle is the quickest way possible back to the x-axis. So we got to find that. So if that's almost 2 turns would be 720 degrees minus 675 degrees is 45 degrees. But your problem's not in degrees. Your problem's in radians. So then you go and turn this back into radians by multiplying that by pi over 180. And when you do that, you get 45 pi over 180, which reduces down to pi over 4. So that's the reference angle. So for this first part of the assignment, they're going to ask you to sketch the graph, or sketch the angle, which is what I'm showing here on the left, and then come up with the reference angle, which is the circled angle that I found. So that's the first half of your assignment. Then what you're going to do is you're going to use that in order to find or evaluate functions. So the first one I'm going to have you do is the tangent of negative 240 degrees. Now, we want exact answers, which means no calculator. Okay, you cannot use your calculator for this. So first thing I like to do for this is I like to draw the angle. So the angle negative 240, I'm back here, I'm somewhere in this vicinity. So my reference angle is this part. So if I take 108 or 240 minus 180, I get 60. That's a 60 degree angle. And if I make that into a triangle, I just formed a 30, 60, 90 triangle again. Just like we did the other day. Okay? Where the short side is 1, the hypotenuse is 2, and the long side is the square root of 3. Now, when it's in quadrant 2 like this would be a negative 1, that would be a positive root 3, and this would be a positive 2. So now when we're doing tangent, like we talked about yesterday, or even the day before, we are dealing with opposite side over the adjacent side. So the opposite side is the square root of 3 divided by the adjacent side, which is negative 1, or negative root 3.